My name is Mateusz Mielity and I am a software engineer at IS Wireless. Our company is a globally operating Polish software developer and IP provider specializing in advanced solutions for 4G and 5G wireless systems. Currently, one of the main domains of our interests is development of software-defined radio access network, which was also the subject of our experiment within SoftFIRE project. SD-RAN is an NFV compliant base station, which is deployable as a set of network functions where the flexible RAN architecture allows using the components either as a physical or virtual network functions. Hence, it allows to provide not only a traditional physical network hardware-based solution, but also a cloud-based architecture capable of running on, for example, mobile edge computing server. The goal of the experiment performed on the SoftFIRE platform was to deploy and validate IS Wireless's proprietary virtualization framework with ETSI NFV Mano-compliant orchestrator. Virtualization framework is a virtualized network function that mediates between the operating system, in this case VNF Mano, and protocol stack. It can be treated as an abstraction layer between those two components. Besides RAN controller and 3GPP stack implementation, it is the main part of IS Wireless's software-defined RAN. SoftFIRE platform provided the open button Mano orchestrator implementation, as well as brought together all the resources donated by different testbeds so that we could use them in our experiments. Access to the testbed was quite easy. All I needed was a VPN connection using the provided configuration and login credentials obtained from the SoftFIRE team. Resources reservation required rummaging through the documentation for SoftFIRE, Open Button and Tosca to get it all working. Start was a bit rough because I thought that the scripts I created were proper, yet the deployed VNFs didn't behave as I expected. The problem I had was that configure lifecycle didn't trigger. Finally, after some testing on a reduced case, I figured out that the names of the shell scripts executed in lifecycle phases were very important. After this hurdle was overcome, resource reservation became much more controllable. I would say we were continuously starved for testbed resources, but that was influenced by both our use cases, which required a lot of resources, and by quite heavy usage of the testbeds when we were doing our experiments. I guess that switching to doing experiments in the off hours helped a lot with that. We benefited from the collaboration with SoftFIRE in three ways. First, we got hands-on experience with Mano platform and were able to make sure the binaries we usually tested straight on POSIX-like OS would work in the cloud. Second, we were able to confirm that our whole virtualization strategy is viable and managed to test throughput and network latencies in a real-world cloud. Without our access to SoftFIRE, we wouldn't be able to test our assumptions about the cloud/data center environment. Some of those assumptions we had were incorrect, and we needed to put some work in the working parts of our VNFs so that they would work correctly. Thanks to our participation in SoftFIRE project, we now know we have some tested VNFs that we could present to our clients. We know they are compatible with Open Button, and we can use this base to create more network functions in the virtualization framework. We are very satisfied that we had the opportunity to perform the experiment within the SoftFIRE tiered open call. The advanced SoftFIRE middleware as well as the economical contribution allowed us to speed up the development of our product and validate it in a fully configured environment. We found the SoftFIRE platform very friendly to use, and we experienced a lot of professional support from the consortium while submitting the proposal and during the whole period of the experiment. Thank you.